Hi, my name is Anthony Johnny Tolentino and I'm going to discuss my final project activity in operating system CPU scheduling algorithm. In this lesson, we will gonna tackle the types of CPU scheduling. Number 1, first come first serve. First process to arrive goes first, meaning the processes are executed in the order they arrived. Second, shortest job first. We can also call it SJF. It is the processes with smallest CPU burst goes first. If the process with the shortest execution time or burst time, it is executed first. And also, there was SRTF or shortest remaining time first. It is a variant of the SJF or the shortest job first scheduling algorithm. In SRTF, the process is executed first with the shortest remaining execution time or the burst time. The difference between SJF and SRTF, it the SJF executes the process with the shortest execution time from the start, while the SRTF executes the process with the shortest remaining execution time at any given point in time. Third is the round robin. It allows the process switching based on a unit of time, meaning each process is given a fixed time slice or time quantum, and the CPU switches between the processes in a circular order. And lastly is the priority scheduling. Highest priority goes first. It is the processes that are assigned priority and the highest priority process is executed. Here are some common CPU scheduling criteria. There are several different criteria to consider when trying to select the best scheduling algorithm for a particular situation and environment, including first is the CPU utilization. Ideally, the CPU would be busy 100% all of the time, so as to waste zero CPU cycles on a real system. In the CPU usage, it should be range from 40% lightly loaded to 90% heavily loaded. The percentage of time the CPU is busy executing the process. Next is the throughput. It is the number of processes completed per unit time. It may range from 10 seconds to 1 hour depending on the specific processes. It is the number of processes completed per unit time. Next is the turnaround time. It is the time required for a particular process to complete from submission time to completion. It is the time taken for a process to complete from its arrival time. Next is the waiting time. It is how much time the processes spend in the ready queue waiting their turn to get on the CPU. It is the time a process spends waiting in the ready queue. And lastly is the response time. It is the time taken in an interactive program from the issuance of a command to the comments of our response to the command. We will solve the types of CPU scheduling algorithm, the first come first serve or the FCFS. The given there are 5 processes, P1 to P5, the arrival time 0, 1, 2, 3, 4, and the burst time of 2, 4, 5, 6, 7. We will gonna compute for the completion time. The first process is the default since the arrival time is 0. The completion time is 2. The formula is completion time plus the burst time. So the second process, 2 plus 4 equals to 6, 6 plus 5 equals to 11, 11 plus 6 equals to 17, and then 17 plus 7 equals to 24. That is how the completion time gets. Next, we will gonna compute for the turnaround time. The formula is completion time minus the arrival time. Formula for the waiting time is turnaround time minus the burst time. The Gantt chart shows the execution sequence and timing of each process. As you can see at the table format, the P1 completed at time 2, the P2 completed at 6, P3 completed at time 11, P4 completed at 17, and lastly the P5 completed at time 24. For the average turnaround and waiting time, we will gonna get for the average of each process. For the turnaround time, there was 50 divided by the total process number of 5 equals to 10. For the average waiting time, there was 26 divided by the total process ID, there was 5 equals to 5.2. And the throughput, the formula is number of processes divided by the total time or the burst time. Since there are 5 processes and the total burst time of 24, we will gonna divide 5 divided by 24 is equals to 0.2083 processes per unit time. Second, we will gonna compute for the SJF or the shortest job first. Since there was no arrival time for the processes, we will gonna assume that they arrive at the time 0. We will gonna look first for the shortest burst time. Since the P2 is the shortest burst time, we will gonna put it in the Gantt chart first. Second is the P4, P3, and lastly the P1. Since the first burst time is 2, we will gonna add it to the second burst time of P4, the 3 is equals to 5, plus the third burst time of P3 is equals to 10, plus the last burst time of P1 plus 16, 10 plus 16 equals to 26. Same formula for the average turnaround and waiting time. For the turnaround time, there was 43 divided by the total process ID. 43 divided by 4 equals to 10.75. For the average waiting time, there was 17 divided by the total process ID, there was 4, so 17 divided by 4 is equals to 4.25. And for the throughput, the formula was again the number of processes divided by the total number of burst time. There was 4 processes and the total burst time of 26, so 4 divided by 26 is equals to 0.154 processes per unit time. Lastly, we will gonna compute for the round robin algorithm with the time quantum of 2. Since there was no arrival time in the table format, we will gonna assume that the processes all arrive at time 0. We will gonna serve the first process P1 and put it on the Gantt chart. Since there was next process of P2 in the time 2, we will also gonna put it in the Gantt chart. But since there was only 2 burst time in the P2, we're gonna add it on the first burst time of 2, so there was only 4 completion time in the P2. Next, for the P3, we will gonna add its 1 burst time, so there was 5. And lastly, for the P1, since its execution didn't finish, we will gonna put it lastly in the Gantt chart and add the remaining time, so it will have the completion time of 7. Next, we will gonna compute for the turnaround time. The formula is completion time minus the arrival time. Since there was no arrival time, all of our subtrahend was 0. 7 minus 0 equals to 7, 4 minus 0 equals to 4, and P3, 5 minus 0 equals to 5. And for the waiting time, the formula is the total in the turnaround time minus the burst time. 7 minus 4 equals to 3, 4 minus 2 equals to 2, 5 minus 1 equals to 4. And for the average turnaround time and average waiting time, we will gonna have to get its average. For the turnaround time, there was 16 divided by the total process of 3 equals to 5.33, and for the average waiting time, there was 9 divided by the total process of 3 equals to 3. And lastly, for the throughput, the formula was number of processes divided by the total burst time. Since there was 3 processes and the total burst time of 7, we will gonna divide 3 by 7 equals to 0.429 processes per unit time.